This video covers an introduction to matrices. So what I want you to do is just read every statement. That's what we did in class. I'm going to go over it quickly. And whatever is highlighted is because I think it's the most important things. So we're going to start working with matrices to solve systems of equations. First we need to get familiar with some of the terminology. First, a matrix is a rectangular array of numbers enclosed in brackets. The dimensions of the matrix are given by the number of rows and the number of columns. An example here, we have matrix A. So that matrix has 2 rows and 3 columns. So what we say to denote the dimensions of the matrix, we call it 2 by 3. And that's what I have written here. We don't say 2 times 3, but 2 by 3. And that represents 2 rows, 3 columns. Every entry, every single number inside a matrix has a specific address, which is the location inside the matrix. So for example, if we look at number 2, which is here, that will be in the first row, first column. So the address we say is A11, not A11, but A11. First row, first column. Next, we have number 1 inside the matrix. So that is in the second row, third column. So we say the address is A23. Matrices could be added and subtracted. We're going to do that next week. In that condition, with one condition, that they have the same number of rows and same number of columns. If they don't have the same number of rows and columns, then they cannot be added or subtracted. Matrices can also be multiplied by a number. We call that scalar multiplication. Quick example of that will be something like 3 times the matrix 1, 4, 5, 6. So what we do here is that we must distribute the 3 to every single entry inside the matrix. And so that will be the matrix 3. 3 times 4 is 12. 3 times 5 is 15. And 3 times 6 is 18. That's what we call scalar multiplication. Now, we could also multiply a matrix times a matrix, and we refer to that as matrix product. Now, we do have to satisfy one condition, and that condition is that the number of columns in matrix A equals the number of rows in matrix B. And so I have an example here. If we look at this first matrix, matrix A, I'll just erase it. So matrix A, the dimensions are 2 rows by 3 columns. The dimensions of matrix B are 3 rows by 4 columns. So what we need to look for is that the number of columns in matrix A, in this case is 3, is equal to the number of rows in matrix B, which is also 3. So those two numbers are equal, that means that we can multiply. If we look at the next example, to multiply matrices C and D, we look at the dimensions of matrix C, and they are 3 by 2, 3 rows, 2 columns. Matrix D is a 3 by 5, 3 rows, 5 columns. So if you notice here, the number of columns is a 2, the number of rows is a 3. So those two numbers are not equal, and therefore matrix C times D cannot be multiplied. So we say that the product is undefined. Now, number 2 here, it talks about what are the dimensions of the resultant matrix. And so it says here that provided that the number of columns here, the number of rows here equal each other, the product is going to be an M by P matrix. And for that, we take the numbers on the outside. So those will be the dimensions of that. So to find what the dimensions of the product A times B will be, we consider the numbers on the outside, and that's what I have written here, 2 by 4. Okay, so as homework, you will be doing this exercise, multiply matrix B times A, but I want you to focus on these 3 matrices here. And I say the 3 of them because if you go to the next page, you see here another problem, A times B and B times C. By the way, matrix multiplication is not commutative. Okay, so we started doing some examples in class, and I'm going to cover them. I'm going to cover all of them. So to begin with, I want you to label each entry using the address of each entry. So in this case, this one is 1, 1, first row, first column, first row, second column, first row, third column, first row, fourth column, and so on. So go ahead and do that. So now we're going to complete the product here of matrix C times D. That's what we're doing. And so before that, we need to verify the dimensions of the matrix. So this matrix C is a 3 by 2, 3 rows, 2 columns. Matrix D is a 2 by 4, 2 rows, 4 columns. So the condition is that the number of columns on the first matrix must equal the number of rows on the second matrix. So since those two are equal, that means that our product CD is possible, and the dimensions of that matrix will be 3 times by 4, which is what we have here. Now, I started doing this with in the class, but we ran out of time, so I'm going to go ahead and finish it. And so the reason we have here a grid with 3 rows and 4 columns, you can see 1, 2, 3, 4 columns, is because those are the dimensions of the resultant matrix. So now the numbers that we have here came from multiplying the entries from the first row of the first matrix times the first column of the second matrix. And so those are the numbers that we see here. So we multiply -3 times 3, and then 1 times 1. So we did that, and -3 times 3 is -9, and then we added 1. So -9 plus 1 is -8. For the next entry, I use the first row times the second column. And so that was -3 times -1, that is here. And then 1 times -1. So -3 times -1 is +3. 1 times -1 is -1. So here, there's no need to use a plus and a minus. We could just say 3 minus 1. And so that is +2. If you notice, I'm writing those numbers here. So -8, +2. And then the next one came from multiplying the first row, and in this case, times the third column. So that was -3 times 7, and 1 times 3. And so that number that came from there was -18. So now I'm going to do the next one. And the next one is for the entry 1, 4. So that means that we need the first row times the fourth column. And that will be -3 times 10 plus 1 times 5. So -3 times 10 is -30. 1 times 5 is 5. -30 plus 5 is -25. Now I'm going to move on to the second row. And so now I'm going to be using the second row first times the first column. And that will be the entry that will go here. Second row first column. So I will multiply 5 times 3, then negative 2 times 1. And remember, we're supposed to add those two quantities. So 5 times 3 is 15. Negative 2 times positive 1 is negative 2. So 15 minus 2, it is 13. And so that is the number that goes here. So now I'm going to pause the video, and I'm going to finish the matrix product. I would like for you to work on your own, and then just check your answers with mine. Okay, so these are the final numbers that we got. And so at this time, I would like for you to just write down the product using the numbers that I have circled, and that will be the answer to the matrix multiplication, C times D. So those numbers will go here. So we have 13, negative 3, 29, 40, 1, negative 1, 3, and 5. So this is the end of the video.